Hello, YouTube. This is Luis, and we are back for week 3 of CS 4540. This week's topics will touch on neural networks like the previous weeks, but we will also talk about LLMs or large language models. And so we'll be touching on 3 key themes for this video. The first being a discussion on the YouTube video for backpropagation. The second, a video on LLMs, or a brief explanation thereof. And a broader discussion on what symbolic and neural net AIs are and their similarities and differences. So for this first video, we talk about backpropagation. Now, backpropagation refers to the process of altering weights and biases in a neural network's inner layers to reflect the desired outcomes of the output layer. And so in the video, we see the same example we've seen for the past 2 weeks, which is a system designed to recognize handwritten digits. In the video, we see that the values for other digits are higher than that of the desired outcome, which is 2. So we see that 3 is at the highest, and 2 is actually one of the lowest. And so the video talks about having to change the values uh, of these digits so as to have 2 be the greatest, which is 1 in this instance, and every other digit be 0. And so we know to change the weights of these values. And so how does that happen? This happens in a process where we prioritize increasing the value of 2 of 2. And this is done by altering the weights of the connecting values. We get as close to the desired outcome as possible, while also keeping in mind that we can alter the weights of the previous layers to influence the result. If I can quickly quote directly from the video, quote, "This is where the idea of propagating backwards comes in. By adding together all these desired effects, you basically get a list of nudges that you want to happen to the second to last layer. And once you have those, you can recursively apply the same process to the relevant weights and biases that determine those values, repeating the same process while moving backwards through the network." End quote. And, that's just an example for this particular input example for the number 2, right? And so the same process would be repeated for every example in the training set, for every digit possible in the output layer. And so you see this process, can take pretty long for just one example. And so you have to repeat this process over and over again for every everything in the training set, in hopes that this can function properly for any images that will be added uh, after the fact, right? Outside of the system's knowledge base. But that's the basic process of backpropagation and how you can alter the weights and biases of a neural network to ultimately reach the desired outcome of a particular input. And it's just really interesting to see how much effort goes into it. And so now we talk about large language models. Now, a large language model is a mathematical model that predicts what word comes next in any given piece of text or input. But instead of predicting one word with certainty, it predicts all possible next words and chooses the next word based on a particular degree of certainty. It can also choose to predict a less likely word um, at random to look a lot more natural, right? Um, Training such a model functions similarly to turning the knobs of a stove, right? To adjust a flame, you turn the knob, to the left or to the right to, increase or decrease the flame. Uh, and it functions similarly in a large language model, right? And these are called parameters or weights. Changing and tuning these parameters will change the probability that the model gives for the next word in a given text or input. Um, and the video talks about how the large and large language models basically just refers to the amount of weights or parameters the model can have at any given time. Backpropagation then can be used to tweak the parameters in such a way that it makes the model more likely to choose the true last word than all the other words, right? And so the video gives a great example where, in the last picture, right, to your right hand side, um, what's in blue is fed into the large language model, where it purposefully omits the last word. It sees what word would be suggested with the given parameter tunings. And if the last word is not actually the top word in the probabilities, the parameters are adjusted so that the actual word can be put to the top. And that's essentially how large language models work. Very similar a process to backpropagation, actually. Um, and so it's interesting to see just the correlation between these two videos in explaining how the parameters of a large language model, or just any neural network in general, works. And then finally, we'll wrap up with a discussion on symbolic versus neural net AI, right? So symbolic AI, you can read all of this basically, but I can summarize it. Where symbolic AI functions on a system of symbols and relations between these symbols to process information. Um, it only uses explicit knowledge to perform these tasks, and as such is easy to backtrack through to follow its logic. As such, they exhibit less bias, being limited to the information fed to it, assuming there is no bias in the rules themselves. So it's very straightforward kind of AI, um, simple, easy to follow through, um, and so it's used mainly for simpler tasks. Now, neural nets learn from data parameter and adjustments through its training on the data, which in a sense allows them to generalize from examples. Um, they can also model complex relationships, making them great for tasks involving image and speech recognition. However, because of their fine tuning of parameters and complex network, it makes them hard to backtrack through, um, or find explanations to their predictions, just simply based on the fact that there's uh, so many nodes, so many connections, so many biases that it makes it hard to keep track of. Um, so basically, symbolic AI is much simpler in terms of the logic, which makes them great for simpler tasks and makes it easier to follow along with. While neural net AIs uh, work on a large system of connections, um, which makes them more complex, which makes them harder to follow along. And yeah, uh, that's the basic relationship between those two. Um, and that'll basically wrap up week 3. Thank you so much.